Dear student, in this lesson we are going to study about some important point in chemical reactions. Chemical reactions are everywhere. Think about when you are cooking. There's a flame in gas burner. That is the energy which emit due to the reaction of LP gas and oxygen. To take energy, there may have some reactions, or some reactions take place by absorbing energy. In your life, in your body, glucose you can eat as food, and while you are respiration, oxygen can take into your body, and your body will take some chemical reactions to emit carbon dioxide and water to get you energized. Therefore, in everywhere, in everything, if you have some changes, there may have some chemical reactions. How do you know when a chemical reaction take place? Sometimes it may have color change, there may have precipitate or gas evolve, some odor or temperature change, change in acidity, you can check your acidity, and any other observation you can see due to the chemical reactions. In chemical reaction, you want to write some equations we call chemical equation. Those are the some special symbols that you should use to write down chemical equations. As you know, in basic chemistry you can write down some equations, and I think you are familiar with those symbols. Next important point in a chemical equation is the balancing. After you write a chemical equation, you have to balance it to make sure that the same number of atoms of each element are on each side. How would you balance this equation? For example, change the coefficient or stoichiometric number to make the number of atoms of each element equal. Think about this reaction which take place while you are burning using biogases. Biogases, most of time they will emit methane. While you are cooking with gas burners using biogases, that methane will react with oxygen to form carbon dioxide and water. Then you can write down this chemical equation. Then first thing, you have to balance carbon. As you know, in this equation, this is carbon in the left hand side and this is carbon in right hand side. Therefore, only one carbon atom in this chemical reaction. Therefore, you have to put 1 to both sides. Actually, you don't need to put 1 to interpret for single molecule. If you want to interpret 2 or more, then you have to put your number. Otherwise, you don't need to put. Therefore, I'll keep this as same. And next thing, you have to balance the hydrogens. In here, in this example, in this methane, you have 4 hydrogen atom in the left hand side. Therefore, you have to balance hydrogen, because here only 2 hydrogen. Therefore, you have to put 2 into the chemical as the stoichiometric number to balance hydrogen. Therefore, as you know, now there are 4 hydrogens in the right hand side. Therefore, now you can balance hydrogen in left hand side to right hand side. Next thing, oxygen. Now you want to balance oxygen. How you know how many oxygen atoms? Here 1 oxygen multiplied by 2, therefore 2 oxygen atom for this water, and here 2 oxygen atom, therefore totally 4 oxygen atom. Here O2 as oxygen here, therefore you have to put 2. Then as you know, here in left hand side there are 4 oxygen atom, and also you have 4 oxygen atom in right hand side. Therefore this is the simple way you can balance these equations. Then when you are writing any chemical equation, please balance before you are going to calculate or any methods before you are going to use. There are several types of chemical reaction. We can classify it according to their nature. First thing, synthesis. Synthesis mean you can say if there are two or more compounds combined together to form some complex forms, we call synthesis. And decomposition, it's mean you can separate out single molecule into two or several parts, we call decomposition. And single replacement is you can substitute one molecule or one part of the molecule or one atom by another atom or another number of atoms to replace, and that substitute part and some can leave. Next one, double replacement. It's mean you can combine two into one place and another two into other side. Therefore, as you can see in this image, we can say double replacement. There are several type of these kind of reactions. That is why I took this basic nature of the chemical reaction. First part is synthesis. In a synthesis reaction, two or more complex substances combine to form a more complex substance. For example, I will take real example. Hydrogen react with nitrogen to form ammonia. This is the process we call Haber process in industry, how to form ammonia using hydrogen and nitrogen. When you balance this one, here two nitrogen atoms are there, therefore I will put 2 here, and here in H3 now hydrogen, number of hydrogen is 6, therefore to balance hydrogen I will put 3 here. Therefore now you can say this is the balance equation. This is an example to make you as synthesis reaction. And another example, you can say calcium oxide. What you can form, as you know, that calcium hydroxide, removing water, we can form calcium oxide. This is called lime, what you can paste in wall. When you constructing building, you can say this is calcium oxide. Now calcium oxide react with carbon dioxide to form calcium carbonate. It is some kind of stable form. This is we call, this is solid, this is gas, and this is also solid. In previous example also, this is gas and this is also gas and this is gas. That is how you can write your equations. So next thing, sodium metal. It's a metal, highly reactive metal. It can react with chloride to form NaCl or table salt, as you know. Here half we can put to balance. So then solid, gas, solid. This is another example for synthesis reaction. Next example is decomposition reaction. A decomposition reaction is a substance breaks into more simple parts. For example, I will take water splitting. Water, if you can apply an electric current or voltage you can divide this water into hydrogen gas and oxygen gas. So this is one example of decomposition. Next example I will take a ferric hydroxide. In ferric hydroxide, when it exposed to heat, it will decomposition to Fe2O3 solid plus H2O liquid. This will evaporate. As you can see in a iron bar, when drop water, so around the water surface you can see some brownish color compounds. Those we can say that before rusting they have ferric hydroxide. Then after drying you can see in iron surface rust. Rust is a ferric oxide. Therefore this conversion ferric hydroxide into ferric oxide and water, it's a some kind of decomposition reaction. Another example I will take calcium carbonate, limestone, burn at around 900 Celsius. It will decompose into lime and carbon dioxide gas. So this is one example of decomposition. This is also the famous reaction in the lime industry in Sri Lanka. Next example is replacement. In replacement we can say there's a two type. One is single replacement, another one is double replacement. In single replacement, one element takes place with another element in a compound. For example, you can say if you dip a zinc metal in a copper sulfate solution, what will happen? You can see the zinc metal will dissolve to form zinc sulfate, and you can see the copper metal will deposit. Therefore this we can say it's a single replacement. What will happen? This copper 2 plus here convert into copper, and zinc 2 plus, how you obtain this zinc 2 plus? From oxidation of zinc metal. So therefore what will happen? It's replace copper into zinc and zinc into copper. We can say this is a single replacement reaction. You can understand more about this kind of redox reaction in next slides. And next thing is double replacement. It's actually the anion and cations of two compounds switch places and form two entirely different compounds. For example, I will take barium chloride solution. Think about, you have a barium chloride solution and you have a sodium sulfate solution. If you mix these two solutions together, what will happen? You can see there's a precipitate barium sulfate, and in aqueous solution remains sodium chloride. 2 sodium chloride is a balance equation now, Q. So then if you mix these together, think about this test tube which contains barium chloride. This is a solution and another solution with sodium sulfate. If you mix these together, what will happen? You can see a precipitation is barium sulfate and the solution remains sodium chloride. Therefore you can see totally different compounds. What happened? They switch the places, barium into sodium and sodium into barium. That is we call, it's a type of double replacement. We can again classify reactions according to the chemical nature. You can say acid base reaction, redox reaction, precipitations, photoreactions, and complexation. Let's see what are those. First type of reaction is acid base reaction. Let me first introduce what is acid and what is base. So according to different definitions, we can say what is acid and what is base. First I will take Arrhenius definition. In here, as you mentioned in the Arrhenius definition, acid dissociate in water releasing H3O plus or H plus ion. The base dissociation in water to release OH ion. For example, we can say HCl. HCl in water, it will convert into H plus Cl minus. It means H plus release in water. So then we can say it's acid or sodium hydroxide. Convert into Na plus OH minus. So then OH minus release in water. aqueous aqueous. So therefore in aqueous solution, sodium hydroxide is a base and HCl is a acid. Next example, next definition is Bronsted-Lowry definition. In Bronsted-Lowry's definition, mentioned as acid are proton donors and bases are proton acceptors. In here, I will take example for ammonia. NH3. In ammonia, you can see there's a. Therefore, when there's a H plus ion, what will happen? Ion can take this one. Then what will they can form is NH4 plus. That means this can accept a proton. Therefore, ammonia is a base. And again this ammonia again can convert into NH3 plus H plus. So therefore this is acid. This base. Next example I will take HCl. In water it can convert into H plus. So therefore it releases H plus. Donor. Therefore this is an acid. Okay. So the important thing is Bronsted-Lowry definition than Arrhenius equation. In Arrhenius equation the definition related to water and aqueous solution only, but Bronsted-Lowry definition we can use for both gases, solids and even aqueous solutions. And next is Lewis definition. In Lewis definition, acid are electron pair acceptor and bases are electron pair donor. For example, here also ammonia, same ammonia, we can say ammonia with aluminium chloride. Let me AlCl3. If this react, what will happen? This can donate aluminium and they can form this kind of solution. Aluminium, Cl, and NH. Here remaining one, this is minus. They can form this kind of compound. For here we can say this donate electron pair and aluminium accept one electron. Therefore we can say this is aluminium chloride is a acid and base is ammonia. Therefore we can say different kind of acid and bases. So then let's we introduce what is acid base reaction. Sodium hydroxide, as we know, aqueous solution is a base now, and react with HCl, aqueous, convert into NaCl plus H2O. This is an example of acid base reaction. And another example I will take, NH3 is base, as you know, gas react with HCl, let me think, then what will happen? NH4Cl aqueous. So this is some kind of acid base reaction. So therefore we can take several examples for acid base reaction, and you should know is what is acid and what is base according to the given theory. Type of reactions are redox reaction. Let me first introduce what is oxidation state, oxidation number to understand redox reaction. So then first I will take some example, hydrogen chloride or HCl. In this HCl molecule there's a covalent bond. When you consider the electron density of this covalent bond is more towards chlorine side, because chlorine atom is more electronegative. Therefore in this electron density more towards chlorine side, therefore I will put some marks as minus for high electronegativity atom and plus for low electronegative atom through this bond. Therefore the oxidation number of hydrogen I will put +1 and chlorine as -1. Then I will take another example, sulfur trioxide, SO3 gas. In here you should know first the Lewis structure. This is the Lewis structure of sulfur trioxide. Then consider a bond between sulfur and oxygen. As you put in our previous example, you can put minus to oxygen and plus to sulfur. Therefore I will put in every bonds this is plus and this is minus. In this bond this is minus and this is plus. For this bond this is plus and this is minus, plus minus, plus minus and plus minus. For every bond I will put plus and minus. So then you have to calculate what is the oxidation number of this sulfur central atom. Then you have to calculate every plus. Here its number is +6. When you consider this atom of oxygen, the total number -2. Therefore every oxygen atoms have -2, -2. Therefore in this compound sulfur oxidation number is +6, and for every oxygen oxidation number is -2. So there are some easy method to calculate the oxidation number for oxides or oxyanions. I will take one example for common example as MX and O. MX, there's a common oxide, MX OY plus O minus N. Then if it's N is 0, then MX OY, that's a oxide. Or if there's a plus or minus ion, we can say it's a oxyanion or cation. So this kind of compound, the oxidation number of M oxidation number you can calculate is equal to 2y plus or minus n divided by 2. For example, I will take MnO4 minus. For here oxidation number of Mn is 2 into 4 minus 1 divided by 1. What is the value? Is equal to plus 7. Therefore in MnO4 oxyanion the manganese oxidation state is plus 7. So then you can calculate using the same equation, or you can understand the oxidation number using Lewis structure. Anyhow, you should know what is the oxidation number of your atoms in that particular molecule to understand what is redox reactions. Now I will take a redox reaction as I take in our previous example. I will take that example, zinc metal dip in copper sulfate solution. What will happen? You can obtain zinc sulfate solution and copper metal. So here, when you calculate the oxidation number, as you know in our previous example, zinc, there are no bonds with any other electronegative atom, therefore the oxidation number is 0. However, in here, this is zinc sulfate solution. In here, this zinc sulfate exists as zinc 2 plus iron, therefore we can say this is plus 2. When you consider copper, here plus 2 is the oxidation state, and here the oxidation state is 0. Therefore, during the reaction, what will happen? The zinc oxidation number converts 0 to plus 2. Therefore, the increment of the oxidation number we call oxidation. And here copper plus 2 to 0, that means reducing the oxidation number, we call it's a reduction. Therefore, the first word of red and the first two letters of ox, we call this a redox reaction. This is the example I took. So therefore, if this kind of any reduction and oxidation take place, we call that kind of reactions as. Next type of reactions are precipitation reactions. As we discussed in our previous example, barium chloride aqueous solution mixed with sodium sulfate solution, you can obtain a barium sulfate precipitation and sodium chloride solution. This is the example I have taken. This is, as you know, the precipitation obtained using this reaction and a clear solution of sodium chloride. This type of reactions we call a precipitation reaction. Next type of reactions are photoreactions. In photochemical reactions or photoreactions, atoms or molecules absorb energy from any source of electromagnetic radiation and convert into some excited state. We call the formation of radicals. Then it will use to break in chemical bonds and to make new bonds. For example, actually I will not take some complex reaction as example, but as you can see in your clothes, when you put a cloth, colored cloth in sunlight, the radiation from sun will drop into your clothes, and what happened, your clothes will disappear, the color disappear. So this is because of some organic compounds which has some double bonds. So then this will break by making some OH radical like compounds. Actually this some reactions are somewhat complicated, therefore I will not take examples, and I will not going to explain the reactions. You should know only the type of reactions are there. Photoreactions which affect electromagnetic radiation to take place those reactions. Next type of reactions are complexations. So here there are several ligands react with a metal atom to form coordination complex. For example, I will take this copper sulfate solution. In the copper sulfate solution, this copper in aqueous solution, copper exists as copper 2 plus ion. In this ion, around this copper 2 plus ion, there are water molecules. There are several water molecules. Therefore, the color of this solution appear as blue. But if you put ammonia into this solution, what will happen? If you put ammonia to these solutions, the complexation reaction take place. Then what will happen is, around this copper 2 plus ion, some ammonia molecules, 2 plus ion, ammonia molecules are gathered. Then what will happen? This become dark blue. So therefore, this kind of reaction will take place by complexation. Thank you very much for listening. I believe that you took good knowledge in chemical reactions, the types according to different classifications, and I think you can refer more about these chemical reactions, and please study more to answer for your exam questions. Thank you very much.